So, yeah, let's start. Please welcome Italo with big applause.
Hello, everyone. I would start saying that I'm so glad to be here. Such a big achievement and such an honor. This is my first PyCon Japan, and such an honor to be here in the stage presenting. Like a few months ago, I wouldn't even imagine that I'd be here. And I would also like to congratulate the organizing team for this such amazing event so far, and also like to thank you, everyone that's present in the audience, for your attention and presence. So, okay, as I mentioned, it's my first PyCon GP. Probably none of you in the audience know who I am, and I will take some advantage of this opportunity to just say a little about me before we get our powers, get some powers and know about Python collections model. So I was born and raised in Brazil, and this year I recently got my bachelor's degree in computer engineering, University in Brazil. And I am part of Python community since 2019. I got involved with Python community by PyLate São Carlos. At the time, MENS could help with the PyLate chapter's activities. And I feel so welcomed, and I feel so engaged with the language that I was one of the persons that can by language that stays for the community. I have 3 years of experience working with software engineering, and if I've just worked like a few months with Python, and I don't work with Python in my day-to-day, but the community makes me feel engaged to learn more about it and make such these presentations. I'm also regular at cafes. I always go up for good conversations and meeting new people. So if you see me at the event later this presentation, please feel free to reach me out, discuss any topic, technical, not technical, any tips for someone that's going to live in Japan right now. I really need a tip of how to reach the correct exit at Shinjuku Station. Like every time that I went there, every try that I have, it's so difficult to read it. So yeah, so now let's talk about what matters. Get our powers, Python collections model. So before we talk about Python collection model, it's important to understand what are collections in Python. So collections are basically container data types. So Python, we have some built-in that probably you're used to it, such as lists, sets, tuples, dictionaries. And the collections models provide some more specialized containers, that structures that brings more performance alternatives to these built-in containers. We know that for some problems, lists are better to use than a dictionary. Others, a tuple is better than use lists. So collections bring high performance alternatives to some specific problems, and that's what we're going to talk today. And also, collections model is a Python standard library, so it doesn't cause any dependency, or you don't need to install anything. You can just import it to your project, your code, and use it. And it's a very popular model. Probably many here in the audience probably knows about this model. But talking with some friends of the Python community from different fields, data scientists or software developers, many of them doesn't know the existence, and when I knew, like, my brain just zones out, and would like to make a talk. And yeah, this library has the standard library since Python 2.4, so this year they completed 20 years of existence. And today we're going to talk about these containers. Don't worry if you don't know the names of this. Just present which we're going to cover in this presentation, which will be the name tuple, deck, default dict, order dict, and counter. We're going to cover like almost all the containers of the model. I know that there are a few more, but if I talk about every container, I have to be here like for hours talking, and I just have 30 minutes. And I also not talk about every feature of each container because, like for the same reason, we just have 30 minutes, and I'll just present the main features for you. So the first one that we're going to see is the name tuple. So the name is very suggestive. So name tuple is a factor function to create tuples subclasses with meaningful naming fields. So you can create visual tuples, but you can define meaningful name fields, so you can access the fields by name and not just by the index. And it's a very good it's a very good collection when you need to create like some simple class just to store data, and you don't want to like overhead defining like the full classes, the class, the construction function, and type everything. So at the right of the slide, you can see some example. The syntax is you just import name tuple from collections model, and you instantiate name tuple, you define a class name, and you set a list or a list of the fields that you want to have in your tuple. So in this case, I just created a name tuple for personal data, which have the fields name, age, and city. And I instantiated one name tuple with my name, my age, and the city that we are right now, which is Tokyo. And at a name tuple, you can access fields with a name set of index, such as we do with classes. Like here, I can access the name, just the name, but we can also, like, its behavior is X tuple, so we can also access using index. If I use the index 1, which refers to the second position, we have value of age, which is the second field of our tuple. I would like to bring another example to show you how name tuple can like enhance a lot of the readability of the code and make things less ambiguous. So here we have an example of the divmod function of Python. For those who don't know, divmod function is a function that you pass a dividend and advisor and returns a tuple with the quotient and the reminder. And just by curiosity, this illustrative division at left is how we learn how to make operational division in Brazil. And for those who are not familiar with quotient and reminder, just reminds. The quotient is how many times the divisor can fit in the dividend, and the reminder is what remains. It remains. So in this case, like we divide 12 by 5, and 5 fits like 2, and 12, 10, and remains 2. But you see that in this case, it's kind of difficult to understand which value in the output tuple is the quotient and the reminder. So like the quotient is the first index of the tuple, is the second index. Which one? And like this is a small example. So even in a small example, when I have like 2 values that are equal, we have to run some tests to know which value it is. But we can enhance a lot of the readability of our code with name tuple if we create like a custom divmod that if we define, such as in this example, a name tuple with fields quotient and reminder. And also important note here, you can define fields with lists, but you can also define here with a string separating the fields names with blank spaces. And here, just like the function you return, the output of divmod operation inside a name tuple. And you see that's really easy to get, like which is the quotient, which is the reminder. If I want the quotient, I don't have to think like which index is the quotient at divmod, which is the reminder. I just put the meaningful name, and I get the values. And there are also other cool features of name tuple. So you can define default values for fields, like such as classes. So here is another name tuple for personal data. Define it here above, which have the fields name and job. And I set a default value Python developer. And if I create essentially name tuple person with just the name, it will create successfully without raising any error, and with the default value for a job. And also, probably, some of you may be thinking that it'd be cool to be using like with another container, such as dictionary, and they have some methods for it. So they have a private method as dict that you can have the values for any name tuple as a dictionary. And also, I didn't explain, but yeah, a name tuple behaves as a tuple. So a tuple is an immutable container can change the data inside it. And that's another cool feature of named tuple, because if you want to ensure that no one will change the data inside of her tuple or anything like that, of her class, named tuple is a good container to solve this issue. But the named tuple doesn't have a method to replace, so you can replace a value in a field. But as I mentioned, now this is immutable. So what replace does? In this case, replace just create a new named tuple, just modifying the fields that you provide that argument of the method that you want to change. And that's why I have to attribute like person replace to the object, to its object, so I can update the values in the named tuple person. I hope you get it, like how we can increase a lot the readability of our code with named tuple. And now we're going to talk about deck. And deck is a double enqueue. So it's a list container that allow that we can efficient add values at the beginning, to add and remove values from the beginning at the end of a list. So if you want to use some that structure for first in, first out containers, or like such as queue or stack, this is a very good alternative, because different from Python's list, when you try to insert values in the beginning or remove or set values at the beginning, that take much more operations, because you have to shift values. At a deck key, you can insert the values with constant time and cost efficient, but more performantly. For those who doesn't understand how it works, I'll try to explain now. At high level, really high level, how does it work when you try to remove or add a value in the beginning of a queue? Beginning of a list in Python. So at the left side is a representation of appending value 1 at the beginning of list. So in a memory of a computer, like the spaces in our memory, each one has an address. These are like just random values. And when you create a list, Python allocates some memory for our list. And this list, in this case, it was initialized at address 150, and allocates some memory until 154, and has the values 2, 4, 8, and 16. But if you want to add a value at the beginning of this list, we cannot simply add the value at the address 149, because at the address 149 maybe can have another data storage, some part data storage that we cannot get rid of it. So what Python does when we pop a value at the first, we like do the method pop at index 0 at the first position, they shift each element to the right, such as in the second line, and then it adds the value 1. And it is a small list, but let's imagine that we have a list with like 1,000 million of elements. And if you just want to add a value at the beginning, how many operations it would do? And for remove, like the same. It's like since it's stored the address where it starts the list, you have to shift to the left when you're moving the first position. And at deck, it's different. So deck is implemented with a double linked list. If you don't know what double linked lists are, don't be worried. You just need to know that a double linked list, the values are in random positions at the memory, and they point to the next element and to the previous one. So you see at the beginning, above that, when you try to append the value 1 and have this list with values 2, 4, and 8, their addresses are random, and they point for each other for the previous value. And we also have this head, which points to where our list begins. So when we would like to add the value 1 in this case, we can just allocate a new space in memory for integer, in this case 1, and we point to the first element in our list and set to point to the initial of list to the value that we just added. And for removing, it's the same thing. We just point the head to the second element, and the value is to be stored, but it will be junk. And with just like one operation, we could create the we put starting value at the beginning of our list without shift the values in memory for other addresses. So now that we know how Deque is much more efficient implemented than a list for removing and add values at the beginning, here are some of the methods that allow us to use their superpowers. So they have the same methods, like almost the same methods as lists. So we have the append to the end of the deck, the pop to remove the ends, the extend to add multiple elements. I think probably you all are used to it. But if you want to choose the superpowers of deck, you can use append left to append a value to the beginning of our deck, pop left to remove a value at the beginning of our deck, and another cool method that deck has that lists down is extend left that can add multiple elements to the beginning of our deck in reverse order. And I would like to bring some example here at right, some practical example. So the syntax, it's import deck, and you instantiate it. You can pass it iterable or not, so you can convert a list to a deck, and you can define or not the maximum length. I will talk about it later. Let me see, just okay. So let's suppose that we want to create a queue of tasks that we have to do in our day. And we add some tasks, some like process user registration, send email notifications, update user profile. But then you receive a task that like a critical bug happens in your company and you need to resolve as soon as possible. So you can use append left. This is how you use append left. You can just use it at the beginning. And you see that since even though it was the last, like it was appended at last, it is in the first position of our deck. And then if we do our tasks, which was represented with the pop left, you see that they will remove from the beginning until the end. And yeah, I mentioned that you can set a maximum length for the deck. This is a very interesting feature. So you can define a maximum length, and if your deck reach the maximum length and you try to add a new value to the end of your deck, they automatically remove the first element of the deck. And if you try to add a value at the beginning of the deck, with the maximum length reached, they automatically remove the last element. So here let's suppose that we're trying to track the recent files that we open, and we can change a deck like this with maximum length of 3, and we can add like 3 example files. And okay, it was correct. So, and when you try to add a new file, a file 4 for a deck, which is full, you see that they automatically remove the first element, which was the file 1. Also, another cool feature is that deck has another method which is rotating. It's very useful, like in the case of the tasks. Let's suppose that you have many tasks that are blocked, and you need to do it later, and it was in the front of your queue of tasks to do the day. You can just rotate them to the end without popping and adding again. And the method rotate, by default, they rotate one by one, clockwise the elements of the deck. But you can pass a number of how much you want to rotate. And if it's a positive number, it will rotate clockwise. And it's a negative number, it will turn counterclockwise. Okay, so now I would like to present the default dict. The name is also very suggestive. So it's a container to handle missing keys. So the default dict is a subclass of Python dictionary that automatically provides some default value when we are missing keys. So we have to avoid us to have like key errors. Probably when you try to counter the number of elements, with a dictionary, you get some like key error to forgot to create a new key, and you have to deal with that. The default dict handle this, so it's a very good alternative for choose when you're grouping or counting elements and avoiding the key error. So the use is very simple. So you can just import from Python collections. The syntax is you instantiate the default dict, and you set a default factory. And here I have an example in which I would like to count the occurrences of the words in a list. And in this case, since I want the default value start with 0, so since we want to count the number of occurrences of words, I set the factor as an integer, but you can set any other factors like, such as lists, string. And when I count the words, I don't need to worry if the key exists or not. I can just iterate by them and update the value inside the key of the dictionary. So here's some example, like if you want to, but in this case, like data scenario. So if you want to group the employees by the departments, we have a list of each employee in the department. In a conventional way, we would do a dictionary. We would iterate by the employees' elements, and then we would check if they're missing or not, and then we would add to our list or not. But with default dict, we can make much more simply. So at the right, you can see that we can just instantiate it with the factory list, that we create an empty list if the key is missing, and you can just iterate as you usually do, and update the values at the department. Okay, so the next container that we will learn is the order dict I would like to present. So the name is also very significant. There's another subclass of dictionary. Probably some know that. And like a hash map, they don't remember the order in which items are inserted, and that's the reason they were developed. But probably some of you know that since Python 3.6, the dictionaries maintain their search order by default. And now probably you're thinking, why use order dict? So the order dict has some other methods that the conventional dictionary doesn't have, which is move to end, and PyPython move to end moves the search order to the end or to the beginning of an key, and the PyPython removes the last insertion or the first insertion. So here we have some example of the cache of files that we open. So we can just instantiate the order dict, and then other files, and then after we had it, we can move some file to end. We move to end, and move to end and PyPython also have the argument last, that if we want to move to the beginning or pop in it as the first item inserted, pop the first item inserted, we just set it to true. And last is one of my favorite containers, which is counter. And yeah, name is also very representative. Like counter is a container to make counting easy. So it's also another subclass of dictionary that is designed to count the occurrences of elements in iterable mapping. And why you should use? Because we saw that like for counting with default dict, traditional way, we have to iterate by each of them. And with counter, you can do with just one line of code. And also provide a lot of other methods that are useful for counting and for data visualization, such as see the most common elements. We can update our counter and do arithmetic operations, and so on. So yeah, what we saw just now is that this example right here. If you want to count the occurrences of characters in this word Mississippi, for example, we have to iterate for each letter and check if the key exists for don't get a key error, and we can improve with default dict. But how can we do it better? How we can get our power raised for over 9,000? So we can use counter, and with just one line of code, we can count the number of occurrences of any iterable. So now we will really increase our power. And as I mentioned, there are some cool features about like get the most common values. The most common works as a method that can call and retrieve the items from most common to least common. And you can pass some integer to see just the number of values, the number of most common values that you wanted. So in this case, we're having some example with fruits, and I use the counter to do with just one line of code. And yeah, and then I use the most common just to see the two most common fruits in our counter. Also, that's a very good container for data analytics, as I mentioned. So it's very easy to visualize some data. In this case, I want to visualize, like I have a sales counter, how much fruits we sold. And if I want to see from the most that we sell to the least, I can just use counter, most common, and plot the graphic, very easy. And you can also do some counter operations. So let's suppose that we have some stock system, and we have some fruits there, like 30 apple, 20 bananas, 15 oranges. The counter has the method update that you can pass another dictionary with the same keys or not, with values of occurrences, and it will update your counter. It has the value subtract that you must use keys that exist in your counters to subtract values. So let's suppose that we want to put our sales, update for sales or stock. And you can also do like subtract and plus operations with the common operations of Python. With counters, we can do it. And yeah, and then that's this container. Let's just remind about the powers that we learned today. So now we learned about how to write more readable and explicit code using nametuple. We learn about how to, with efficient queues and stacks, and how to efficient remove and add values at the beginning of a list with the deck. And we learn how to handle missing dictionary keys with the default dict, how to remember the essential order of keys with the order dict. Also, order dict, yeah, another cool thing of order dict that it's very self-explanatory that when you use order dict, the order of insertion matters. So when you are writing a code, it's good to use order dict because if some other programmer see your code, when you see order dict, they know that the order of insertion matters. And also enhance the readability of the code. And also we learn about how to count objects efficiently use counter. And yeah, and that's it. If you are interested in more collections that has in the collections model, and if you're interested to know more about the other features of these collections that I just showed for you, they are available at the Python documentation. You can see it. And also, I would like to tell about the Real Python blog. They have a lot of articles from Python collections that I inspired to create this presentation and are very self-explanatory. And that's it. Thank you so much for your attention. These are my social media, and thank you so much.
Thank you for a great presentation, Italo. So, if you have any question, please raise your hand. Okay.
A couple of search told me that you can, of course, have some benefits of using name tuple over dictionary, but I wanted to know from your experience what could be the cases and benefits of using name tuple over the dictionary, like because dictionary also have keys, right? So from your experience, how have you been benefited from using name tuple?
Okay, so just to know if I get the question right, if I get the question. So you're asking like some examples where using a name tuple is better than using a dictionary. Okay, so yeah, so you know that like Python, we can't create, like don't have constant variables. So it has to change. And as a dictionary, you can change a key at any time. Like everyone, like another programmer that will make some modification in your code, they can change the value and maybe make some mistake. But with a tuple is a immutable data structure. So some benefit of name tuple is that if someone tried to change the value of the fields of a name tuple, they will get attribution error. So this will prevent you from get like data that you're not prevent, like not prevent. I don't know if this answers your question, but it's one of the
No, thanks.
benefits.
Thanks.
Anyone else? Okay. So thank you for your presentation again. Yeah, please give a big round of applause to him again.